So here we are again. These are additional problems that aren't in the other screencast, that part 1, part 2, part 3, because I made those last spring and we did include some of this stuff. And anyway, this was on the quest. Identify the number as prime, composite, or neither. So a prime number is a number that can be gotten by multiplying 1 in itself, and that's it. So the prime numbers are they're natural numbers. Natural numbers. So 0 is not included in this thing. And 1 is not a prime number because 1 is itself. So let's look at these other numbers. 1 is a neither. But 2, prime number, because the only thing you can get it by is multiplying 1 in itself. 3 is a prime. 4. Is 4 a prime? Well, you can multiply 1 in itself, but you can also multiply 2 by 2. So 4 is not prime. 5? Yes. 6? No. 7? Yes. 8? No, because, you can multiply 4 times 4, 2 times 4, 8 times 1. Oh, maybe that's it. So not 8. 9, 3 times 3 also gets 9. 10, 5 times 2. 11, that's prime. Only 1 in itself. 1 times 11. 12 can be 3 times 4, 6 times 2. There's a lot of things that make 12. 13, prime. Only 1 in itself. 14, nope, it's an even number. The only even number that's prime is 2. 15, nope, divisible by 5 also. 16, no. 17, yes. So 1 is not. Should have crossed that out. Let's circle all the ones we have so far. 18, no. 19, yes. 1 in itself. 20, no. 4 times 5, 10 times 2. Okay, so not 20. 21, 3 times 7. 22, of course, no. 23, yes. 24, no. 25, no. 26, no. 27, no. 28, no. 29, yes. I'm going to stop here, but we could go on forever because there's an infinite amount. Even in the billions and quadrillions, there are still prime numbers that can only be gotten by multiplying 1 in itself. So, back to this problem. 1 is neither. Now we know what prime numbers are. Number 2 is make the prime factorization of 175. It says write the number as a product of prime numbers, and that's what that is, prime factorization. So we'll go 175. And what numbers will divide into 175 evenly? Well, 5 will. There's a whole bunch of others. 25 will too. But we could do, okay, so divide it by 5. If you divide 175 by 5, 5 into 17 goes 3 times. 5 into 25, 5. Okay, so 5 and 35. Can we break down 5 anymore? No. But 35, yes. 7 times 5. Okay, so these are the prime factors. And if you multiply those prime factors, 5 times 5 times 7, or 5 times 7 times 5, you get 175. So you write the prime factorization this way. It's 5 times 5 times 7. Or in shorthand, it would be 5 to the second power times 7. Number 3, order of operations problem. Okay, so we go to the innermost parentheses on this. I'll write it bigger. We have 4, bracket. Bracket's the same as a parentheses. It's just we use brackets and parentheses both because, you know, if we use a parentheses we need something different looking, so we'll use a bracket. But they both do the same thing. So the innermost parentheses has got a 3 to the second power in it. So naturally we do the inner parentheses, but not only that, we're going to take care of the 3 to the second power. Even if that was only with a dot between the 8 and the 3 to the second power, we'd still do the 3 to the second power first. Okay, so we copy everything else. We'll do 3 to the second power, that's 9. And then that would be 8 times 9. And we can just keep the brackets, what the heck. It's plus 7. Keep the bracket. Same as a parentheses. But we'll just stay consistent, say. Alright, now the next thing to do inside the parentheses. Multiplication comes before addition. So we do 8 times 9, that's 72. Plus 7. Still inside the brackets though, so we do that first. 7 plus 72. Now you notice that we could do this as a distribution, but it would be more work. So you do the easiest thing. You can just add the 7 plus the 72 together, and we get 79 times 4. We can do it over on the side. 79 times 4. 4 times 9 is 36. 4 times 7 is 28, 29, 30, 31. 316. 316. We could have also put equal signs all the way down. It just means it's equal to the one above it. They're equivalent algebraic expressions. Okay, number 4, absolute value of 3. Remember that the absolute value is the distance a number is from 0.
This is nice.
Even this number line is, we can even do it without the numbers. The distance from 0, doesn't matter which direction you're going, it could be from like this point here, or we could go from this point. Distance to 0. So this one here is 1, 2, 3, 4. 4 from 0. This one is 1, 2, 3, 4, 5 from 0. See, so this is a negative 4 here. See, there's 1, 2, 3. They're all negatives. And that's 5. There's 1, 2, 3, 4, 5. See, so the absolute value of 5 is the same as the number inside the absolute value things. It's 5. Absolute value of negative 4, since the distance is 4 from 0, that equals 4. So, what do you think the absolute value of 3 is? Of course, it's 3. Distance is 3, right here. Okay, now we're at number 5. Now here starts the ones from chapter 2 that weren't included in that 3-part screencast. So, an equation has a solution, but an inequality has a solution set. For instance, x is greater than 2. There's a lot of numbers there. So as opposed to like x equals 2, that could be this could be the solution of an equation, right? And there's one answer usually to an equation. There's those two other possibilities, and one is that there are infinite solutions, and one is that there are no solutions. But usually what we're looking for is this. When we're solving an equation, we're looking for one answer. But an inequality always has an infinite number of solutions, or it could have no solutions. So x is greater than 2. Again, if we do the number line, that's 0. Okay, so x is greater than 2. we graphed it, we would graph it like this. To make that blue. There. We graph it like that. It's all those numbers greater than 2. It's an infinite number of numbers. And we could write the solution set with set builder notation. It would be like this: x such that x is greater than 2. Or we could use interval notation. And we go, it doesn't include 2, but it's 2 to positive infinity. So that's a solution set. It's a whole bunch of stuff. Number 6. If the perimeter of a rectangle is measured in inches, then the area will be measured in what? Okay, so let's make a rectangle here. That's not bad. Okay, so the perimeter is all the way around. It's a distance. And the perimeter is measured in inches. So let's say that this was 6 inches, and then this one here, let's say that that was 3 inches. Okay, so if we were doing the perimeter of that, the perimeter equals 2L plus 2W. So the length is 6 inches. It would be 2 times 6. The width is 3 inches. It would be 2 times 3. That would equal our perimeter. 2 times 6 is 12, plus 2 times 3 is 6. That would be 18 inches. You know, it's a length. But if we do the same thing, and let's see, let me just divide this up into squares. So you can see this is 3. 1, let me do that in red. 1, 2, 3. And then this is 6 up here. So it's 1, starting from this direction. 1, 2, 3, 4, 5, 6. Area, we multiply the length times the width, and these are inches, right? So we're not only multiplying 6, but we're multiplying 6 inches times 3 inches. It's just like if it was 6x times 3x. We would multiply the 6 and the 3, we get 18. And the 3 and the 6 here, we get 18. But here, we get inches squared, just like here we would get x squared. Because we get all these squares. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's the surface area. So it's square inches. Square inches describes area. So if the perimeter of a rectangle is measured in inches, then the area will be measured in square inches, which we could write like this. So problem 7. Find the area of the circle with diameter 12 inches. And they give us the formula. It's right here. The area equals pi r squared. Okay, so now r is the distance from the edge of the circle to the center. So this is r. And the diameter is the distance all the way across. You know, all the way across from one side through the center to the other. That's the diameter. So obviously the radius is half of the diameter. So if they've given us 12 inches divided by 2 to get the radius, which is 6. And we just plug it in. So we're looking for the area of the circle equals pi r squared would be 6 squared. So we have pi times 36. Or we could call it 36 pi. And if we're going to use pi as 3.14, then we would go 36 times 3.14. And that's just an approximation. So if you multiply it by 3.14 on your calculator, you're going to get 113.04. If you use pi on the calculator, you're going to get 113. If you round it to two places, you'll get that, 0.10. So you have to pay attention to what they're asking you to do. Or generally, they're going to, if you're going to look for the solution, a number solution, then you're going to use 3.14. So don't use the pi key on your calculator if you're going to calculate for 3.14. That's all I'm saying. And that'll do it for this one. Oh no, one more thing. So it was the diameter was in inches, right? It was 12 inches. So area is not in inches. Area is like square inches. So it'd be inches square. That's important. It's not a length, it's a surface. Number 8, find the surface area of a box with the length 4 feet, width 5 feet, and height 2 feet. Okay, so we've got the, come on, there it is. Alright, we've got the equation for it, or the formula for it right there. So all it is a plug-in problem. See, this is length, this is the width, and this is the height. So we just plug it in. So surface S equals 2 times the length times the width. Length is 4 feet, so it would be 4 times the width is 5, plus 2 times the width times the height. So that would be 5 feet times the height here, 2 feet, plus the last one is 2 times the length times the height. So 2 times the length, 4 feet, times the height, which is 2 feet. See, so actually it's quite easy. Just plug in the correct numbers into the formula. I mean, you have to know that L means length, and W means width, and H means height. But that's all there is to it. So then we just solve it. So on this first one, 4 times 5 is 20, times 2 is 40, plus 5 times 2 is 10, times 2 is 20, plus 4 times 2 is 8, times 2 is 16. And then we add them together. And you do it the easy way. I'm going to add the 40 and 20 first. That makes 60. Then I'm going to add that to the 16. That's 76. Now 76 what? It's a surface area. And it was, the dimensions were in feet, so it's got to be square feet. Number 9, solve the formula for the specified variable. Okay, this says P equals S1 plus S2 plus S3, and we're solving it for S3, right there. So, that doesn't mean that we're going to find a number. We're not going to get like S3 equals 5 or something. We're going to get S3 in terms of the other variables that are already there. If there were numbers there, they would be in there somehow too. So we're just basically rearranging the equation using the methods we've learned for solving equations. Okay, so I'm going to rewrite it. P equals S1 plus S2 plus S3. Alright, since I'm solving for S3, I want to get rid of everything else. This. Okay, so to get rid of that, I've got to subtract it from both sides, not just the right side. Okay, so I'll go P minus S1 plus S2. And that equals S1 plus S2 minus S1 plus S2. And then, of course, we have our S3 on the end, still there. Okay, so this thing, I'm subtracting the same thing, or I'm adding the opposite. Either way, it gets to be 0. So that gives me P minus S1 plus S2 equals S3. And if I want to, I can take this negative and distribute it through these two. So if I did that, I would get P minus S1 minus S2 equals S3. So both of these solutions are fine, like this one or this one. Okay, solve the problem. Number 10. Using the formula P equals 2L plus 2W. P being perimeter, L being length, and W being width. If the perimeter of a rectangle is 50 feet and the length is 10 feet, find the width. So this is an easy one. We've been doing this all along. Remember, the perimeter is how far it is around. Okay, so if the length is 50 feet and, let's see, the rectangle, oh, I goofed up. The whole thing is 50 feet. I missed the point here. That happens. Okay, if the perimeter of the, so P equals 50, all right, and the length is 10. So we've got our equation. In the place of P, we're going to put 50. Okay, and that's 2 times the length plus 2 times the width. So, and our length is 10 feet. So 2 times 10 plus 2W. Okay, so now we're just solving for W because we're finding the width. Right? And so we just do the same thing we've been doing all along. So first we'll simplify both sides. So we have 50, 2 times 10 is 20, so we have 20 plus 2W. Okay, so we want to get this term alone. We always get our variable alone, so we will add a negative 20, negative 20, negative 20 to both sides. And that gives us 30 over here equals 2W. Then, if we move it up here, we divide by 2. And these cancel. Oops. Keep forgetting to turn on the pen. Okay, those 2's cancel out. 2 into 2 is 1, so we have 1W, or just W. And 30 divided by 2 is 15. And then we can check this. Alright, so the length is 10 and the width is 15. I don't know why that would be, but okay, the width is 15, length is 10. You notice when we have, so that's 10, and this is 15 also. So we've got 2 times 15 is 30, 2 times 10 is 20, add them up, you get 50. So, it's right. Or you can just stick it back into the formula. And 50 what? Oh yeah, 50 what? Well, 50 feet, because this is feet. These are all lengths. These are all feet. Feet, 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 and feet. All right, number 11. Solve and graph. Write the answer in set builder notation. Okay, so we got 2 minus a is less than negative 2. So, 2 minus a less than negative 2. Okay, so we can do the same thing to these inequalities as we do to equal things that are equal equations. The only difference is if we divide or multiply by a negative number, then we have to turn the sign the other direction because the values suddenly flip-flop. Okay, so in this case we're going to try to get our variable alone again. get the variable alone. So we'll add a negative 2 to both sides. Negative 2, negative 2. So that gives, this becomes 0, so it's negative a is less than a negative 4. Alright, but we don't want to know what negative a is less than. We want to know what a is less than, or a is greater than. So we're going to divide by negative 1. Divide or multiply. For some reason I'm always dividing. I guess I got into this habit. Anyway, it doesn't matter. Negative 1 into negative a makes it a. We turn the sign around because we're divided by a negative. And negative 4 divided by negative 1 makes it 4. So a is greater than 4. So let's make our, let's put 0 here. We'll make this 1, 2, 3, 4, 5, 6. You know, you make the graph at your convenience. So we'll, since a is greater than 4, we'll use the parentheses, right? And then we'll use an arrow. The parentheses means greater than, but it doesn't include 4. And if we were going to do set builder notation, which it asks us to do, it would be x such that a is greater than 4. Use these braces. If we wanted to do interval notation, well, we basically got the interval notation right here. My wife's going to the movies.
Oh, sorry.
4. 4. So it starts at 4. You know, you go from left to right with this interval notation. Use the parentheses because it's greater than, and it's not exactly 4. Otherwise, if it was exactly 4, we would use the brace. I mean the bracket. Okay, then we use a comma, and it goes to infinity. And of course, we use the parentheses on infinity. There we have it. Good job. Number 12. This is our last additional problem, though I might stick some more problems in just for the fun of it, because I know you love doing these problems, right? Okay, I'll rewrite it and make it bigger. Another inequality, a little more complicated. Let's see if it, yes, okay. So 24n minus 48 is less or equal to 6 times 3n minus 9. Okay, so we do the same thing we do if we're going to solve an equation. We simplify both sides. So there's nothing on the left side to simplify, right? But there is on the right side. We have a distribution. So we'll multiply the 6 times the 3n and the 6 times the negative 9. 6 times 3n, 6 times the 3 is 18. So we have 18n. We had 3 n's, we multiplied it by 6, now we have 18 of them. 6 times negative 9 is negative 54. Okay, on our other side, we still have 24n minus 48. Okay, we want to get our variables all on one side, so I'm picking the left side, so I will add a negative 18n to both sides. Now, keep in mind you can start with the constants, the numbers, and do those first if you want. Doesn't matter, do the numbers first. And this is the stage where we do the adding or subtracting, right? And if you're going to do it underneath, like I'm doing here, always add the opposite to both sides, so you don't make a mistake. Okay, so then this becomes the negative 54, because 0 plus the negative 54 is a negative 54. And copy the sign down. Okay, 18 from 24 is 6, so we have positive 6n. 24 is bigger than the 18, and the 18 is negative, but the 24 is positive, so we keep the positive sign. And then negative 48. Okay, so now we want to get this, we want to get the 6n alone, so we'll add 48, the opposite of negative 48, to both sides. Okay, so we have, on the right side we have a negative 54 and a positive 48. Adding those together, we actually subtract, right? We subtract the 48 from the 54. The 54 has a larger absolute value. It's just further from 0, so it's the 6 is negative. Okay, then we just copy the inequality sign. Positive 48 plus a negative 48 is 0. So now we have 6n is less or equal to a negative 6. Divide by 6. Notice we're dividing by a positive 6. Okay, so those cancel out, and these cancel out. So what we have is n equals a negative, or n is less or equal to a negative 1. N is less or equal to a negative 1. Now let's go back and look at what the problem was. What the problem was asking us to do. It says solve the inequality, write the answer in interval notation. Okay, but I'm going to do both, but we'll start out with that. We'll write it in interval notation. So if you write it in interval notation, actually you become aware of how easy it is to graph. Alright, so n is less than or equal to negative 1. Okay, so we start from the left. If it's less than, it goes to negative infinity. So we're going to start with negative infinity. Negative infinity, which gets the parentheses. Okay, so it goes from negative infinity to negative 1, and it includes negative 1, so we use the bracket here. See, so if we were going to graph this, 0, 1, okay, I didn't mean to make these red, but here they are. Oh, negatives. Okay, so it's less or equal to negative 1, so we'll use this thing and we'll draw the arrow in that direction. If we were going to use set builder notation, which it didn't ask us to do, but if we did, you just put x such that, and then you put that thing in. N is less or equal to negative 1. Actually, set builder notation is very easy. And if you're wondering why I didn't go to the movies with my wife, it's because I don't go to the movies much, but I'm going to go hiking with my son. And that's that. Okay, just one more inequality, because I think a little more practice wouldn't kill us. Alright, so we have a negative 5 minus 4n is greater or equal to 25 plus 16n. So again, let's get the variables all on one side. There's nothing to simplify up there on either side. See, so we can just move ahead. Okay, so I'm going to add a negative 16n. I'm going to go against my usual procedure. I put a negative 16n, add that to both sides, and that will give me just 25 over on this side. Copy down the inequality because nothing happened, and I'm adding a negative 16n to a negative 4n. That gives me a negative 20n, and then I have a negative 5. Okay. All right. Now I want to get all my numbers on the same side, so I'm going to add 5 to both sides, and that gives me a negative 20n is greater or equal to 30. Okay. So now I'm going to divide by a negative 20. To get my n alone. I don't want to know what negative 20n is. I want to know what n is, a positive n. So I'm going to divide by a negative 20, get rid of the negative and the 20. See? Divide by negative 20 over here. And that gives me n here. Turn the direction of the sign around. Less than or equal to. And I get, because these zeros, these 10s, 30 over 20 is the same as 3 over 2. 3 over negative 2. So 3 over negative 2. Okay, so now I'm going to graph it first. Okay, sorry the graph is not more elegant, but, and actually I didn't need one so big, because 3 over negative 2 equals 2 into 3 is 1 and a half, but it's a negative 1 and a half, right? It's easier to, rather than try to graph an improper fraction, I'm going to change it into a mixed number because it's easier to find where negative 1 and a half is as opposed to where negative 3 halves is. Okay, so negative 1 and a half will be past the 1 right here. Well, right about there. Okay, so that's negative 1.5. Okay, so n is less than or equal to that. So, or equal to gives us the, gives us the bracket. Less than gives us the arrow going that way. If I graphed it in, or put it in interval notation, from left to right, it starts at negative infinity and goes up to and including negative 1.5 or negative 3/2. Now here, see, I'm writing the, oh, it includes it, so bracket, right? Let's make that bracket. I should change the color. Bracket. Okay, and then in set builder notation, x such that, oh, it's n, I'm sorry. N such that n is less than or equal to a negative 3/2. Okay, that's going to have to do it. Bye for now.